I start by giving a very, very short overview of anomaly detection, and I hope we have a good discussion afterwards. As a researcher, I'm not selling a product, so I'm not going to tell you that all is good. I'm going to tell you what I gather from really studying the field, and some good news, as well as some bad news. So, Halloween is on us. Is that why you have orange, by the way? Eric? Orange is the new black. Actually what's happening is times are changing. We've heard this before. The air gap systems are a myth. That we've heard many times. So we have wireless connections. I hear that from the Stockholm's traffic förvaltning here in all the buses and trains and underground stations and stuff. And it's really not on to have the idea that physical security is enough. That's what I read in research. You guys might have a different view on that. There are rising threats. Rising threats we have heard many times, but actually in numbers, we have this study from Vormetrics, 2015 Insider Report, who interviewed 800 top senior executives in the world, half of them in the US, some in UK, Germany, and Japan, and other places. And they say 89% of executives are actually worried. They think that they have serious vulnerabilities and serious issues. As well as that, of course, we have the usual mix of the modern and legacy, which aging issue Vidar explained to you. So all of these are on the table, and we will have failures, and we will have remotely connected devices. Are we going to keep all the remotely connected devices air-gapped? I don't know. I doubt it. Some of us in Stockholm, southern Sweden, have had these grey days. And these grey days are, of course, not a great time to actually go out and look at your remote device, geographically located. It's just an enforcement of the fact that we are going to have people actually having to go and look at these devices. On top of that, there's no evidence that the insider threat is decreasing. You may you may agree with me on that, you may not, but that's what Vormetrics says. Of those executives interviewed, some 55% thought that privileged users could be considered as insiders. Contractors and service providers, large proportion, 46%, and business partners. You all have an ecosystem for actually running the systems, developing systems, procuring the systems. These guys are not all on your site, they're not all under your control. The cloud is coming to the picture, so the notion of insider actually has to be defined and considered. That's my opinion. And if you consider that insiders are not always doing what they are expected to do, well, maybe we should look at anomaly detection, deviations from normality. NIST asks for it, ENISA asks for it. Nobody tells you how. Some people try to sell you things. It's good to know what actually where should it be placed? I mean, Vidar talked about the field level, automation level, information level, the network in between all three. You can place it wherever. Where do I start? That would be a good question. So, detecting the bad is the objective. Of course, we know this metaphor of haystack. So, looking for bad things in haystacks is not easy. It's actually the case that people, at least researchers, think that if you have blacklisting as your strategy. You will not do it because, well, the blacklist has to be updated all the time. It never is updated, and you don't get the zero-day attacks. And the whitelisting, well, you should know your business. Maybe it's worth looking at. The only problem with blacklisting is not the fact that you have to update it all the time. Actually, with these remote devices, sometimes, and we've seen some diode being made of Raspberry Pi this morning, or implemented with the help of Raspberry Pis this morning. This is a study by US Army Labs in 2013, which actually says, look, the sort of IDSs that you have, like Snort, they have such a demand on the resources, on the things they are supposed to run. You won't get it on the small, cheap devices. The actual pressure on the costs will drive us towards having fewer and fewer computational resources, bandwidth resources, memory resources. This is if we actually have to not go on to the really high-end systems. So the Snort 1.2 gigabytes of memory on an i5 dual-core processor is very much incompatible with the Raspberry Pi 512 kilobytes RAM memory at the time when they did this study. There is another report, I think it's worth reading it, by this guy. Do you know, anybody recognize his name? No, no one from UK here. Chris Johnson from University of Glasgow is a he's actually the in advisories to NIST and all that. He actually wrote a report in 2015, SafeComp, and he says there are these barriers to blacklisting ICS. Not only blacklisting, the report actually covers IDS in general, but these are the specific points about blacklisting. So there is a safety issue, there is a security issue. If you want to deal with security, you better not jeopardize your safety. And in order to do that, well, you have to think about how would you go and update the various programs or rules or whatever you want to do on your devices. Certification for safety has certain stringent requirements. Actually, he sees that as compatible with the idea of doing it. Furthermore, if you're doing it not by Microsoft update methods, you also have this idea of going and manually updating stuff. It doesn't go on the remote devices. So, bad news. Note that if you want to do your anomaly detection with building a model of the good, you don't have to build actually rules. You can do model of the normality by extracting state machines, by doing statistical profiling. You can do clustering. You just need to have enough data, look at your data, and extract your normality model. So the fact that you are building up a normality model is through learning. And if you really know your business, or you really want to know your business in terms of what's traveling through my networks, in my systems, in my boxes, in my channels, I better have an idea about this. So I better actually start having a system who learns my normality. Of course, it is this whole idea assumes that while you're learning your normality, no attacks are going on. Okay, so if no attacks are going on, then you can start learning. Learning what? Well, you can learn at those 3 layers that we described. You can learn things at sensor layers, at the automation layer, or at the information layer. And in every case, you can actually do it on the hosts or on the networks, routers, typically TCP dumps. Okay, so you can do with some kind of executable, which executables are allowed to run, which access patterns are normal, which resource usages. This is the good things which you should know should happen in your network. This should be finite. This should not be that changeable. I'm not saying it's not changeable, because it might change. And if it does have the change, of course, the same place where you were with the Chris Johnson issue, that somebody has to update the normality model. But still, you might have to consider that all of these options are open, traffic amongst the nodes you have, your process values, and control system settings. Henrik was talking about process values, right? So that's one type. So modeling the good, how can you do that? Well, I picked a couple of papers from the guys who've done recent work. Among others, people from University of Twente have done some good work, and this is Marco Caselli. He worked with a group of other researchers, and he said, I'm going to detect sequence attacks. Now, sequence attacks are things where the things which happens in your network on itself is not bad, like you open a pump is okay, you stop a pump is okay, but you open two pumps in a certain sequence, maybe is not normal. This is the sort of thing that a normal anomaly detection based on simple events would not detect. And to do that, I think it's one of the more exhausting type of work where they actually look at the host, the traffic, the process values, and they actually collaborated with a water plant and did some 5 days of data collection, and I thought that it was quite interesting, published in Cyber Physical System Security 2015. Good news, it's possible, but actually you have to have a lot of knowledge about your this particular plant. You have to have some performance, and you do get some false positives. So you have to sort of fix the problem to this particular network. Since then, those same guys have actually looked more onto that, and they say in another paper, a later paper, that, well, detecting the bad event sequences and timing deviations, they need a little bit different regimes, so we must do two parallel compositions of the methods. And also, they also bring up the question of, if we are going to look at the operator actions, an operator every now and then intervenes, well, it's not going to be so profile. I mean, if you don't profile it, what is normality? It's, you have 5 days. Did all the operator actions take place during the 5 days or not? Now, another work, this is Robert Wood, a student of mine, a bright new guy. He, sorry, the picture is not so very, but I picked it off the net. Robert did his master thesis on anomaly detection on IEC 104 data. We didn't have a plant, we didn't have any operator who at the time we started this work, so we used my colleague, Matthias Eksted at KTH has access to a lab, an ICS lab, which they use for teaching. So Robert actually went there for 1 week, corrected data, and actually did some anomaly detection, picked up then brought the data into the own lab, started injecting attacks into it, and actually could detect some two types of scanning attacks, man-in-the-middle attack. We started doing something on timing attacks. We had some problems with the BRO framework, which we use from Berkeley. And then we are continuing that work. The next paper will actually go further on that. But that was good news, because actually it did get published in CPSS 2016. It was worth, from a research perspective, to do it. I'm not going to list all the papers that have been done. There is a survey from 2014 by 2 guys in Virginia Tech who actually cover some 28 approaches or various papers, and they look at them all and they say, well, each of them takes one aspect of this business, but none of them actually has takes the holistic view that discovers the differences which are between the OT systems or ICS systems and IT systems, the classic enterprise systems. So there is more work to be done. Among others, they say, oh, there's only 4 data sets that are open to everybody's use. So people go to their local operator. If they are very lucky, they get realistic data. But actually, of those at least 15 which were using SCADA systems or smart grid systems, they were all closed, and none was actually shareable. So how do I know that the method that actually is written in this paper is actually correct, or the best one? Because I cannot compare two methods on the same data. Two different teams of researchers cannot test their method on the same data. Is that really science? Well, I would say that there is a question mark here. Later on, some guys from University of Mississippi, 2012, not later on, but in the meantime, and later on 2016, they have another paper who says, look, test beds should be the object of research. We should actually create test beds, and in 2012, they said we should have something similar to this. They should have some process simulator, there should be some RTUs, MTUs, there should be some network, including wireless, by the way, and we should have, they wrote some Python scripts, and they said, you know, we can emulate these networks. Later on, they've actually created a phasor measurement unit, large and interesting test bed at Mississippi. So back to reality, we would like to do something here. Is there any test beds in Europe? Anyone who knows about test beds, raise their hands, please. Okay, that's nice. There is in Europe and in Sweden, I know. I don't know of any, so no test beds that we can actually do systematic studies on this. So this has been pointed out in research, but on top of that, there is another point with anomaly detection, which points out actually the issue of aging and the physical system actually in a nice way. It says that if you have malfunction in the plant and there is an alarm shower, you get a lot of false positives from the anomaly detector who says something is abnormal, but it doesn't have to be a security attack. So that is something to actually think about and know how to deal with if you want to introduce it. Also, they say that once you get an alarm, it's hard to diagnose. Where do I start to looking? Back to the haystack, perhaps. These questions are not resolved and are interesting to look at. So maybe it's a bit of a bad news, but you know, I'm a researcher, I'm here to solve problems. I like bad news. In the reality, we try to talk to people, our stakeholders, and we say, look, what if I would like to collect some data in your network? Would you let me do it? They say, yeah, it's very interesting. Anomaly detectors, I would like to try it out. And then I say, how to collect data? And they say, for example, I mean, this is just an example. This is an ABB router. I picked all the data in here. I picked it just off their, you know, advertisement material. And they say that it has comprehensive security functions to provide all-around protection against network attacks. And I asked these guys, is there a mirroring port on that? And they say, I don't know, have a look at this manual. So I have a look at the manual. Yes, there is a mirroring port. And I say, would you like have someone to turn it on? And I say, well, let's ask our ABB first. And then they say, well, the bandwidth will be reduced. So I asked the guys, do you know how much bandwidth do you need? Maybe you don't use all the bandwidth. And they say, so no names mentioned. I think these are common problems. I think this is actually one of the barriers to actually taking realistic data and putting it in your... So back to the barriers, you have the bandwidth issue. Do you know how much data you carry and how much extra bandwidth you have? Can you actually justify buying a physical tap to actually take, and would you be prepared to put it in sequence between your passage from one node to another node, and no mirroring, but actually in case the tap doesn't work, your system will be disrupted, your operation will be disrupted. If you are going to reconfigure, can you actually tolerate the reconfiguration, the disruption to the business? These are questions which have to be studied, and I would say they are sort of mini bad news. I have to deal with them if I'm going to take this a bit further on. Motivation for the utilities. Well, some utilities might say, if I don't see any incidents, why should I actually spend all this time doing the logging and collecting data? And some of them, they say, well, you know, where do you think I should put my anomaly detector. And I say to them, well, you just have to decide yourself, not the place where the highest threats are, but not necessarily, but maybe the places where you are hurt most. I wouldn't know that. How do I know where are you hurt most? So all of these questions are problems that have to be addressed. So my bottom line, we need test beds to evaluate and know what we are doing in research, but also the guys who are out there, they should know their systems. If they don't collect data, and Robert Lee has talked about it at least 246, if you don't collect your data, you don't know what's going on, what chances in life do you have to actually know what else is going on in your network? So this work we are actually doing in collaboration with a range of stakeholders. Several of them are in our reference group for the project, and the project is in the context of RICS project, Resilient Information and Control Systems, a 5-year project financed by MSB in collaboration with my colleague Matthias Eksted at KTH and Jonas and, not Jonas, Magnus Almgren at Chalmers. Jonas, I have 2 Jonases at FOI, of course, who are collaborating with us on the NCS3, and we hope to make the testbed in collaboration with FOI with extending their IT crate system to IT plus OT ICS system. Thank you for your attention.